Sustainable software engineering is an emerging discipline at the intersection of climate science, software, hardware, electricity markets, data center design. The 8 principles of sustainable software engineering are this core set of competencies that you need to know in order to build and run sustainable applications. But as well as the 8 principles, I would also say there are these 2 philosophies in sustainable software engineering. The first is that everyone has a part to play in the solution. Where I think we've failed in the past is by making sustainability this exclusive club where only if you can show that your work reduces carbon emissions by 50% are you worthwhile speaking to. The truth is that nothing happens in isolation. Everything is connected. Everyone is part of the solution. Small changes lead to big changes. Just the act of normalizing a discussion about sustainability in technical meetings will empower others to raise their voice. That's how you create change in any organization. Everyone has a part to play. The second philosophy is that sustainability all by itself is enough to justify our work. In the past, we had to wrap sustainability in these little pills to make it easier to swallow. Just doing something for the sake of sustainability wasn't enough. As sustainable software engineers, we recognize there are many advantages to building sustainable applications. They're almost always cheaper, they're often more performant, and they're often more resilient as well. But the primary reason we're doing this is for sustainability. Everything else is an added advantage. Sustainability is enough all by itself to justify our work. Being green means different things to different people, and that makes it quite a challenge when it comes to communication or even just figuring out what to optimize for. As Microsoft's sustainability, we have a couple of different ways to look at sustainability. We look at carbon, waste, water, and ecosystems. But for sustainable software engineering, we're narrowing down our focus to just carbon. And what is carbon? So carbon is short for carbon dioxide. It's the most common greenhouse gas in the atmosphere, and greenhouse gases act as a blanket warming up the planet. It's actually a natural phenomenon. Greenhouse gases have been in our atmosphere and increase and decrease in concentrations over hundreds of thousands of years, which means that the temperature on the surface of the planet of the Earth changes naturally in a cycle over hundreds of thousands of years. But it happens very, very slowly, so slowly that animals, plants, and humanity just have time to adapt. So imagine forests slowly migrating across continents. That's the kind of geographic timescales we're talking about. But now, through human activities, we're pumping out vast amounts of carbon dioxide and other greenhouse gases into the atmosphere very, very quickly. Too quick for animals, plants, and humanity to adapt to. And what we can do in the engineering space to be part of the climate solution is to build applications that are what's called carbon efficient. Now, we all emit carbon in our everyday activities in life. But what we need to do and what our goal is for each gram of carbon that we emit into the atmosphere, make sure we get as much value out of that as possible in our use for it. When buying fridge freezers, do you want to buy a fridge freezer with an energy rating of F, or do you want to buy a fridge freezer with an energy rating of A? That's what I think of when I think of being green. Being green is all about being efficient. And being carbon efficient is about building applications that add the same value to you or to your customers, but emit less carbon. That's why the first principle of sustainable software engineering is to build applications that are carbon efficient. Most people think of electricity as clean. I mean, when you plug something into a wall socket, your hands don't get dirty, there's no smell in the room. But in fact, electricity is one of the most dirtiest things on the planet. And that's because most electricity is still created through the burning of fossil fuels, mostly coal. And that's why an application that consumes less electricity is more sustainable, because electricity is a proxy for carbon. So as sustainable software engineers, it's our responsibility to understand electricity a lot better. And that's why electricity, and specifically building applications that are energy efficient, is the second principle of sustainable software engineering. One really important thing to understand about electricity is its unit of measurement, because it can actually be quite confusing. The standard unit of energy, a volume of energy you might think, is called a joule, and power is a rate of energy per unit of time. So a watt, 1 watt, is 1 joule per second. And in fact, the most common unit of energy is something called a kilowatt hour, which just means the amount of energy you would get if 1000 watts or 1000 joules per second was running for 1 hour. What is the volume of energy you would get from that? And that's a kilowatt hour. So kilowatt hour is a term most often used to describe the amount of energy used by servers, computers, and software. So I've mentioned before that electricity is dirty, but how dirty is it? Well, it depends on where it was made. If it was made in a fossil fuel power plant, like a coal power plant, then it's going to be quite dirty. If it was made in a renewables plant, like a wind or a solar farm, then it's going to be quite clean. And this measure of how dirty your electricity is called carbon intensity. And all electricity has this number. The electricity coming through your wall socket right now has this number. And it changes by region. If you're in a region where most of electricity is created through coal power plants, your carbon intensity is going to be high. If you're in a region where most of your electricity is created by renewable power plants, your carbon intensity is going to be lower. But it also interestingly changes over time as well. When the wind's blowing or the sun's shining, then it means that there's more energy being created through renewable plants, which means that your carbon intensity is lower. But when the wind stops blowing or the sun isn't shining, utilities have to make up the difference by burning more coal or burning more gas, which increases the carbon intensity. And that's why carbon intensity is the third principle of sustainable software engineering. Consume electricity with the lowest carbon intensity possible. Which leads to a really interesting use case, which is called demand shifting. Try running your workloads at times or in regions where the carbon intensity is less. And what's really exciting about this approach is that without changing a single line of code, just by making a decision about when and where you're going to run your application, you can reduce the carbon emissions of your application. Everything releases carbon in its creation and will also release carbon in its destruction. And that includes computing devices. By the time you buy a computer, it's already emitted a whole load of carbon, more than it will probably ever emit through its consumption of electricity. We call that carbon the embodied carbon. And there's also an expiry date. Computers get old, they can't handle modern workloads, and they just need to be refreshed. So if you think about it that way, hardware is a proxy for carbon. So as a sustainable software engineer, if our goal is to be carbon efficient, we must also be hardware efficient. That's why the fourth principle of sustainable software engineering is embodied carbon, and specifically build applications that are hardware efficient. And so there's many things you can do, but one thing I think you can do as a sustainable software engineer is to help extend the expiry date on hardware. Computers don't wear out. There are no moving parts. They just become obsolete. They become obsolete because we are constantly creating software that pushes the limits of hardware. Let's stop doing that. Let's start writing much more efficient code. Let's reduce the unnecessary features of our application. Just because there's 10 cores, do you need to use all of them? Do you need to max out the graphics card on a computer? If we can learn to do that, then we can learn to extend the expiry date on hardware. If 1,000 kilograms of carbon was released to create a laptop, and we can make that laptop useful for 6 years instead of 4 years, that's hardware efficiency. I used to think that if I used my server 50% of its max utilization, that it consumed about half the electricity that it would have consumed if it was running at 100%. That made sense to my brain, but I was completely wrong. There's actually this concept in computing called energy proportionality. And it's quite complex to explain, but I think in words the best way to explain it is the more you use a server, the more efficient it becomes at converting electricity to useful computing operations. For example, a server running at about 10% utilization might already be consuming 50 watts, whereas the same server running at 90% utilization might only consume another 50 watts, so 100 watts. Servers become more efficient the more they are used. And there's various reasons for this, but one of them is this thing called static power draw. Things like memory or your network card, they consume electricity or the same electricity regardless of how much the server is being used. CPUs also have static power draw. It's kind of proportional to the number of cores in a CPU. The more cores it has, the more the static power draw. Because of this static power draw, even when servers are completely idle, they still consume a lot of electricity. And that's why laptops and mobile devices, that's why they power down when they're idle, but powering down a server is just a lot more challenging. That's why the fifth principle of sustainable software engineering is energy proportionality, and specifically running servers at a high rate of utilization. It's easy to think of a network as just a line or a couple of lines in a technical drawing connecting a few computers together. But a network is just a load of physical hardware, things like routers and even servers. All those devices in a network consume electricity and they all have embodied carbon. And all that the internet is just a network of such devices. And they all typically run off the local energy mix of the local grid, however clean or dirty that is. As a result, any data you send or receive over the internet emits carbon. The amount of carbon emitted depends on really quite a lot of factors, but I would say the two most important factors are the amount of data that you're sending and the distance it's traveling across the internet. That's why the sixth principle of sustainable software engineering is networking and reduce the amount of data and distance it must travel across the internet. Demand shifting is the strategy of moving workloads to regions or times when resources are constrained. Demand shaping is a similar strategy, but instead of moving demand to a different region or time where there are enough resources, we shape our demand to match existing supply. If the supply that we're talking about is electricity, then whatever renewable energy is available right now, we change our application so that's all it uses. It's a really subtle concept, but I think a really interesting one and leads to some really amazing ideas for architects and designers. A great example of this is video conferencing. Rather than streaming at the highest quality possible at all times, when bandwidth is low, when this resource is constrained, they often shape the demand by reducing the video quality and prioritizing audio instead. Another example of this is progressive enhancement for the web. The web experience improves depending on the resources and bandwidth available to the end user's device. And this whole thing is linked to this broader concept in sustainability, which is all about reducing consumption. We can achieve a lot by being more efficient with resources, but at some point we're just going to have to consume less. As sustainable software engineers, to be carbon efficient means perhaps at times when the carbon intensity is high, instead of moving a workload to another less carbon intensive region, we just cancel it. We reduce the demands of our application and the expectations of our end users for a bit. That's why the seventh principle of sustainable software engineering is demand shaping. Instead of shaping supply to match demand, try shaping demand to match supply. When it comes to measuring the carbon efficiency of your application, unfortunately it's pretty hard to do right now. There's nothing end-to-end which measures the carbon of your application in a granular enough way for it to be useful to engineers. There are some tools, not always the easiest to use, but there are some tools that enable you to measure electricity usage, and we know that reducing electricity usage of your applications is a good proxy for reducing carbon. Electricity and embodied carbon is often factored into the price of services. So if you build an application to run as cheaply as possible, again, that's usually a pretty good proxy for carbon. Networking is one of the easiest things to measure, and we know that reducing the amount of data and distance it has to travel, that's a good proxy for reducing carbon. And performance, if you can architect an application which performs better for the same level of utilization, not just by throwing more servers at it, then that's again just a good proxy for reducing carbon. But when it comes to optimization, one piece of advice is to look end to end. The more you understand the carbon efficiency of your application from the front end to the data center, the more options for optimization will just pop up in front of you. And so putting that effort in to understand the full stack often yields very simple solutions that improve the carbon efficiency dramatically. So if you're focusing just here, there might be an amazing solution right here, and if you just looked at it end to end, you'd see it. That's why the eighth principle of sustainable software engineering is focused on end-to-end optimizations that increase the overall carbon efficiency of your application. And as you become more proficient as a sustainable software engineer, this will just become easier.